Alright guys, welcome back. We are starting a new topic today. We are done with transversals and we're moving into circles. So today we're going to talk about sector area. Now before we get started on what a sector is and how we find sector area, we're going to do a really quick recap on circles. Specifically, we need to know about the area and about the degree measures of a circle. So we're going to start with area. So area of a circle, I'm going to write that as A. We find by multiplying pi times r squared, and here our r is the radius of the circle, which is measured from the center of the circle out to the edge of the circle. Alright, next we're going to talk about the degree measures inside of a circle. So if I measured the degrees inside a full revolution of a circle, I would get 360 degrees. So one full circle has 360 degrees inside of it. All right, now that we got that out of the way, we're going to talk about our new vocabulary. So the first thing we want to talk about is what exactly a sector is. So a sector is a portion of a circle that is enclosed by two radii, and radii is just the plural of radius. So we have two radii that enclose a portion of a circle. So I'm going to color it in yellow on our image here. So this entire area that is in yellow is a sector. And I'm going to go ahead and highlight the word sector as well. So that entire yellow highlighted area in our circle is called a sector. All right. The next thing we want to define, our next vocabulary term, is central angle. So all a central angle is the measure or the distance between our two radii. And we measure it in degrees. And we use this symbol theta to represent our central angle. So we've seen theta before when we talked about right triangles, and we're using it again here in circles, and it still means the same thing. It just means an angle measure. So here, this angle measure is specifically between, this is one radius and this is our second radius. They have the same measure, that's important to remember, but we're measuring the distance from this radius to this radius here, and that is our theta, or our central angle. Alright, so today we're going to focus specifically on how we solve for sector area. Alright, before we do that, I want us to look at this half circle. So when I have half of something, it just means that I am dividing by 2. Alright, so that's all that half means. And that's how I got this theta here in the center, is I took my total degrees, which is 360, and divided it by 2 to get 180. And now we're going to use that relationship between our central angle, which is 180 degrees, and our total degrees, which is 360, to figure out the relationship between a half circle and a whole circle. So this is going to seem a little repetitive, but we get 1/2 here. With this relationship, we can apply it to find the area of a half circle. So to find the area of a half circle, we're going to take our regular area formula, which is pi r squared, and multiply it by that 1/2 that we got when we found the relationship between our central angle and our entire circle. All right, and we can rewrite this as pi r squared over or divided by 2. Alright, so now we're going to take the same thing. Now we have a quarter circle. So quarter circle here just means that we are dividing by 4. And that's how we got that 90 degrees. 360 divided by 4 gives me 90. And we can prove that relationship by dividing. And we again get 1/4. So to find the area of a quarter circle, we're going to take this ratio that we solved for up here and multiply it by our formula for area of a circle. So we can go pi r squared times 1/4, or we can rewrite it as pi r squared divided by 4, sorry, because we have 1/4 of a circle. Alright, so this works really well when we have relationships that are easily identifiable, like quarter circles or half circles, or even like 1/3 of a circle or 1/6 of a circle. But what happens when we have a circle like this, where our central degree measure is a weird number that won't divide evenly into 360? So when that happens, we need to set up a proportion. And this proportion is going to compare the relationship between the central angle measure, or our theta, and the total degrees in our circle. Alright? And we're also going to look at the relationship between the sector area. I'm going to put that in yellow. Sector area and the area of the whole circle. So proportions are always set up as part over whole equals part over whole. This is how you calculate percentages, like out of a certain number of questions on a test. So in this example specifically, we are going to compare our degrees on the left side and our area on the other side. So I'm going to draw my fraction bar here. For degrees, we're going to put them in red, and then area we're going to put in blue. That was supposed to be blue. And we're going to put our equal sign between them. So our whole or our entire portion always goes at the bottom of these fractions. So in degrees, this is going to be our total degrees. So total degrees, I need to put that arrow somewhere else. This is going to be our total degrees, which we know is 360. But for our area, it's going to be the area of the whole circle. So to find the area of a whole circle, we always set up as pi r squared. Alright, so now the part of our whole when we're looking at the degrees is always our theta, right, or our central angle measure. And for our area, it's going to be our sector area, which we're going to abbreviate using the letter K. Alright, so here K is just going to stand for sector area. I'm going to write that in. So K is just sector area. This is total area. And up here we have our central angle. Alright, so this is how we set up the proportion for any central degree measure, central angle measure that we get. So I'm going to just rewrite it under here. So to find sector area, we're always going to use that proportion. Alright, so we're going to go through some examples on how we can use this proportion. Alright, so first example is solving for sector area. So when you're solving for sector area, you need to have these two things given to you. So you need to have your central angle and your radius. Alright, so we're going to start by looking at this problem here. So my central angle is 45 degrees. And I don't have my radius, I have my diameter, but I can divide this by 2 and that'll give me my radius, which is 4 feet. I'm going to write that here, r equals 4. Alright, now next thing I want to do is set up my proportion. So I'm going to have theta over 360 equals k over pi r squared. And I'm going to substitute in the two values that I have. I'm going to write these in color. So let's go theta equals 45 and radius equals 4, just so we can see where we're putting them. So I'm going to have 45 over 360 equals k, that's what we're solving for, is our sector area, so we're going to leave it as k over pi 4 squared. Alright, so before we do any other math, I want us to simplify this denominator. So I know that 4 squared is going to give me 16. So instead of writing pi 4 squared, I'm going to write k over 16 pi. And we're going to leave it as 16 pi for now. And then we have our 45 over 360. Alright, so now our next step is going to be to cross multiply. So I'm going to multiply k times 360 and 45 times 16 pi. So this first operation is easy. I'm going to get 360 pi equals 45 times 16 gives me 720 pi. And my last step would be to divide by 360 on both sides. This is not a pi, this is a k. That's my bad. So 720 divided by 360. I'm going to write this over here because I ran out of room. So this cancels and I just have k equals 2 pi. So this right here will be our exact answer. And if we plug that into our calculator, 2 pi gives us about 6.28, and this would be our rounded answer. Alright, on IXL, you're going to want to use your exact because that's what it asks for, but on your exit ticket, you can use your rounded answer. Alright, I'm going to do another example. This one, we're solving for the same thing, so we're still solving for k. And we still have our proportion up here that we're going to use. Except now we have a really, really big sector area. Alright, we're going to start this problem the same way. I'm going to set up what my theta is. So my theta is 315 degrees. And my radius, it gives it to me, is 3. Alright, I have my proportion here. So I'm going to substitute everything that I know. So instead of theta, I'm going to go 315 over 360 equals, I don't know what k is, but I do know that I have pi 3 squared. I'm going to do the same thing. K is still at the top, but I'm going to write this as 9 pi and then 315 times 3 60. Oh, we forgot something over here, but we'll make sure to include it on this one. So we're going to do the same thing. We're going to cross multiply. So I have 360k equals 315 times 9, which gives me 2835 pi. And the last step is going to be to divide by 360. Alright, so k equals, I'm going to see if that divides evenly, so 2835 divided by 360. It does not, so I'm going to have to simplify this out. I'm going to divide both my top and my bottom by, let's go 5, because I see they both can be divided by 5. Divided by 5 is going to give me 5, 6, 7 over 72. That still has a pi. And can I divide both of those by 3? Let's go 767 divided by 3. Yes, gives me 189 over 72 divided by 3 is 24, and I think I can divide by 3 again. This is where it starts to get tricky because you have to keep your numbers in order. So I'm going to divide by 3 again. So 189 divided by 3 is 63 pi over 8. And I think that is, yeah, that's as far as I can simplify it. So again, this is going to be my exact answer. Oh, we're forgetting our units. Feet squared because it's area. But we can also write this in not fraction form, in decimal form. So 63 pi divided by 8 is going to be 24.7 feet squared, and this is rounded. All right, both answers are correct. One of them is just more accurate than the other. All right, so that is how you solve for sector area. We can also use the same proportion to solve for central angle. So we can do this when we have our sector area and our radius. So here the problem tells us that our K is equal to 23.6 miles squared, and our diameter, I'm not sure that that's 75, and our diameter is 12 miles, which means our radius is 6 miles. Alright, and we're going to set up our proportion again. So I have theta over 360 equals k over pi r squared. Zoomed in way too far. Alright, so now I don't know what my theta is, so I'm just going to bring that down. Theta over 360. I do know that my k is 23.6, and I can write this in as well, pi 6 squared. So before I cross multiply, I'm going to simplify this at the bottom. So I have 23.6 over 36 pi equals theta over 360. And now we're ready to, I'm going to make that bigger, cross multiply. So here I'm going to have 36 pi times theta equals 360 times 23.6, which gives me 8,496. My last step is going to be to divide by 36 pi. Notice that I'm leaving it in parentheses. When you put this in your calculator, it is very, very important that you put this denominator in parentheses or you won't get an accurate answer. Alright, so this is going to cancel. I have theta equals 8496 divided by 36 pi, which gives me 75 degrees, and this is my final answer. I accidentally gave the answer away, but that's fine. Alright, we're going to do one more example of this. And we're going to start with the same thing. So my k is 40 pi. This problem is a little bit different. It gives us our area in terms of pi, and our radius is 10. This is going to make it a little bit easier on our part. So now I'm going to substitute. Don't know what theta is, so I'm going to leave that as theta over 360 equals 40 pi over pi 10 squared. We're going to simplify that denominator, so I'm going to have 40 pi over 100 pi equals theta over 360. Alright, we're going to go 40 pi times 360. 40. It's going to give me 14400 pi equals 100 pi times theta, and divide by 100 pi on both sides. And this is really easy. We're just going to cancel out these zeros and cancel out the pi, and we get 144 degrees equals theta. You can put that in your calculator if you want to. You don't have to. Our zeros cancel and our pi's cancel. And our answer is 144 degrees. Alright. And the last thing we're going to talk about is word problems. So we have our ratios that are the same, but before we do anything, we have to figure out what we're solving for. So, and what the problem gives us to start with. So I have an 18-inch pizza is divided into 12 equal pieces. So I want to find the area. So that means I'm solving for K. So now 18 inches. Pizzas are measured all the way across. So that means that this 18 is my diameter. So diameter equals 18. So radius equals 9. And now I want to find what that theta is. So I know I divided into 12 equal pieces. So to get my theta, I'm going to divide 360 by 12, which is going to give me 30 degrees. So my theta is 30 degrees. And now I'm just going to substitute this into my proportion. So I have 30 over 360 equals K, which I'm solving for, over pi 9 squared. We're going to cross multiply. So I have 360K equals 2340 pi, because I still have my pi attached. And now I want to get K by itself. So I'm going to divide by 360 on both sides. And K equals 2340 pi divided by 360. So first thing I want to do is check to make sure that I can divide 2340 by 360. So 2430 divided by 360 gives me a decimal. So we can't do that yet. What I'm going to start by doing in the simplification process is just dropping those zeros, because that means I can divide by 10. So I have 2, 3, 4 divided by 36. I have pi up here. I'm going to divide both of those by 9. Let's see if that gets me something. Okay, so now I have 27 pi 36 divided, and that's as far as I can simplify. So this again would be my exact answer. And if I plug that into a calculator, I'll get 21.2, let me leave it like that, inches squared. And this is inches squared as well. And this is my rounded value. So again, exact is what IXL asks for, so you have to simplify these fractions down. Rounded is what you'll need to do for your exit ticket. Alright, we have one more word problem that we're going to go through, and then we'll be done. So now I'm going to do this in green. I have a cheesecake with a 9-inch diameter. I'm going to highlight that because it's important. We cut it into equal pieces that have an area of 5.3 inches squared. So I want the central angle measure, which means I'm solving for theta. Alright, so I'm going to start by writing in what I know. So diameter is 9 inches, which means my radius is 4.5 inches. And my area of my sector is 5.3 inches squared. And now we're going to set up our proportion. So theta is going to stay there because we don't know what it is, over 360 equals 5.3 at the top times pi times 4.5 squared. Alright, so now we are going to simplify this at the bottom first. So I'm going to have 5.3, 4.5 squared is 20.25 pi equals theta over 360, and now I can cross multiply. So 5.3 times 360 gives me 1908, and then I have 20.25 pi, put that in parentheses, times theta. I'm going to divide by 20.25 pi on both sides. Remember that has to be in parentheses, and this is going to cancel, and I get theta by itself, and theta equals 29.9 degrees, which we are just going to go ahead and round to 30 degrees as our theta, and that would be our final answer. Alright guys, we are done for today. I know this video is a little long. I'm going to go ahead and give descriptions of where each section is, and I will see you guys next Tuesday.